Hello everybody, welcome to my class. So today's topic is the particle in equilibrium state, and this problem has been taken from A level mechanics 1. So let's share the screen. So let's see the problem. The problem states that a particle P, that is, this is a particle P is attached to one end of a light in extensible string. The other end of the string is attached to a fixed point O, you can see in the figure. A horizontal force of magnitude 12 Newton. You can see this is 12 Newton is applied to this particle P. The particle P is in equilibrium with a string taut and OP, this OP making an angle of 20 degree with the downward vertical as shown in this diagram. Then you have to find the tension in the string and the weight of this particle P. So in order to solve this problem, you should have knowledge of drawing the component of the forces first of all, and then for equilibrium state you can you know that the total force, that is the sum of the forces in equilibrium state, is equal to 0. So first of all, let's see that how to draw, just a kind of reminder to you that how we take the component of the force. So let's suppose one example. So say this is a particle, and a force of F Newton is applied on this particle along this direction. So you can see the force has two components, one along horizontal axis, you can also call as x-axis, and another along the y-axis. So in fact, in general, you'll see that along the x-axis, suppose that this is the horizontal axis, and about the horizontal axis, let's say this force makes angle theta with this horizontal axis. All right, and then you can say that along this horizontal axis the component of the force is F cos theta, that you have already seen it before while dealing with basics of the components of the forces. And then also it has effect along y-axis, or you can say this as vertical axis. And then about the vertical axis, you have seen that this component of the force has magnitude F sine theta. So always note that the horizontal component of the force is F cos theta, and the vertical component of the force is F sine theta. All right. Now, which one is horizontal and which one is vertical? You can see this in the orientation of x-axis as well as in the orientation of y-axis. All right. But if you suppose y-axis as ground, then what happens? Y-axis will become horizontal component for the force F, and the x-axis, in fact, it becomes vertical component of this force, but not for this angle theta, but for another angle, this, that is the complement of angle theta. So the whole thing is 90 degree. You know that axes are at 90 degree, so this angle must be here 90 minus theta. So if you are considering 90 minus theta as the angle of force made by this line, here it is y-axis, but instead of this is vertical axis at this time, now it is supposed to be as, it will act as horizontal axis. So that means the horizontal component of force F is always F cos of the angle. So here in this case, the component of the force along this horizontal axis with respect to the angle 90 minus theta is cos 90 minus theta. All right, and then it will become, this axis will become vertical axis with respect to the angle 90 minus theta. So vertical component of this force in this case is F sine of this angle 90 minus theta. So you should be able to handle the component facts in different ways. So do not stuck to a single orientation. Okay, so just you suppose that this is the force and it makes an angle theta with some axis, then along this angle there is the component of force F cos angle of this force made by the given ground. And if this sort of thing, if you suppose as the angle made by this line, for example here it is y-axis or any line, then it will be the horizontal component for the force. All right, so you should not be confusing taking the components of the force in any orientation. And this is also possible that the force may apply like this on this particle, like this also. Then in that case, if it is F, then opposite of that is negative F. And similar thing happens with all these things. That means if one way, if you consider the force as positive, then in opposite way, the same force is taken as negative. All right. So this is the fact that you have to understand while taking the component of the given force. Okay. Now another factor is that what is equilibrium? What is equilibrium state of the forces? So in equilibrium state of the forces, there must be total sum of the forces equals to 0. So let's take an example. So for example, this is a particle and one person is pulling this towards this direction and another person is also pulling this object towards the opposite direction. All right, with the equal amount of the force. So if suppose that this person applies the force F1 and this person applies the force F2, for example, and at the time when both the person apply the same amount of force, say F, and here also this is F, then in that case this particle will not move and hence this particle is said to be in equilibrium state. But what is the difference between these two forces is that one as positive force, then this is opposite to this the force applied by this person, so therefore F2 equals to negative F. So these two are, if these two forces are equal in magnitude but in opposite in direction, in that case the particle is in equilibrium state. So you can see the total sum of the forces in this case is, so total sum of the forces in this case is F1 plus F2, and you know that here F1 means you suppose this as F, and then plus F2 means this is negative F. So plus F and minus F, they got cancelled out and hence this is 0. So as the sum of the total forces applied on this particle is 0, therefore the particle is said to be in equilibrium state. Now let's do this problem. So in order to solve this problem, let's copy out this diagram first of all, and then we'll deal with how to get the tension, the magnitude of this tension in the string, as well as the weight of this particle in this equilibrium condition. So in the first part, it is given that to find the tension in the string. So you can see that this is the value of T that acts towards O, because the force is uh, applied towards this direction, and the tension is always opposite to the force applied. So here you can't see that this is opposite to 12 Newton, but there is some other force towards opposite to this uh, T, uh, which is affected by the components of this 12 Newton force as well as the weight of this particle. So at this time, we'll just consider the component of the force T in this case. So here you can see that if you join this line this way, and then if it is 20 degree, this is already 90 degree here, so that this is uh, 90 degree and 20 degree, that is 110 degrees, and from 180 degree if you deduct 110, then this is going to be equal to 70 degree. So if you consider the horizontal component of the force T along this direction, then horizontal component for the force T will be T cos 70 degrees, and its vertical component at this point you can go up like this. Okay, so vertical component is sine of this angle 70 degree. So you can see that so when, or you can say as, the particle P is in equilibrium state, or you can just leave it like P is in equilibrium, or you can say P is in equilibrium state, then the total forces, the total sum of the forces must be equal to 0. So total forces in this case, you can see that T cos theta is towards opposite to this 12 Newton force. So you can say that is minus 12 Newton force, or you can say 12 Newton force as positive force, but T cos 70 degree as, because this is in the opposite direction to 12 Newton force, so you can say that T cos 70 degree as negative force, equal to this 12 Newton force, or vice versa. Anyway, you can write it, and that is equals to 0. So now this is the case to calculate the things here. So it is T equals to 12 divided by cos 70 degree. If you transpose all it to the towards right, and then take your calculator. So in your calculator, you'll see that after you use calculator, this value is 35.0856528 and something like this, and this is nearly equals to 35.1. If you round this up to three significant figure, correct to the three significant figure, then the force in this case is now 35.1 Newton. So don't forget to write the unit of the force. So in this way, we can calculate the value of tension in the string. Okay, so this is the way that you will mm, find the information based on the given information and the conditions. But this is good for the exam, but for your proper practice, you should have a proper concept developed while practicing. Therefore, don't see the same problem in one way. Try to see the same problem in different ways so that your concept will be even clear. So in order to do so, you can see, okay, so in another way, if you, this is force T, which is tension in the string. And what if you consider the component of horizontal component for T as this along this line? In that case, if this is 70°, it's definitely going to be 20°, because this whole thing is 90°. Okay, and also by geometrical condition, you can see that these two angles are alternate angles between these two parallel lines. Therefore, this angle is 20°. So if you suppose, uh, if you take the component of T about this angle 20°, so definitely this is going to be horizontal component for this force T. So in that case, this horizontal component will be given by T cos 20°. And now for this angle, for the force T, it has the vertical component along this direction now, along the same direction here now. So that will be T sine 20°. So it depends that how we resolve the force, okay, about which angle you resolve the force, and you have to find about along this angle, it has the horizontal component, and just perpendicular to this horizontal component, that is the vertical component for the given force. And also, in the point of view of trigonometry, if you see that relation between sine 70° and cos 70° is that you can say that it is sine 70° equals to cos 9 equals to sine 90 minus 20. So in place of 70, you can write 90 minus 20, which is 70. And you know that sine 90 minus theta is cos theta. So this is cos 20°. So we can relate the things by trigonometry as well. So in this way, if you are going to find the value of T in that case, so still as the particle is in equilibrium state, so now the opposite forces are T sine 20° and 12 Newton. So these two are the equal and opposite forces because the particle P is in equilibrium state. So the total sum of the forces is again 0. So here the total sum of the forces is T sine 20°, and then plus minus 12, or you can write 12 minus T sine 20° as you like, and then this is 0. So therefore T in this case is, after transposing this towards the right, all these things towards the right, so it is divided by sine 20°, and take your calculator, then your answer will again be 35.1 Newton if you if you round this off to the three significant figure. And this is the answer for this question. Okay guys, now you have to find weight of this particle in the second part of this question. This is 2, right? So in this case, the particle is still in equilibrium state, but we have to relate this sort of equilibrium thing with the weight of this particle that always acts vertically downward. So since the particle is in equilibrium state, the total forces, that is the sum of the total forces is, again, this is 0. So in this case, we have to consider W towards downward. You can call this in positive direction, and opposite to this force W is, from this diagram, it is minus T sine 70 degrees, and that equals to 0. And then you already have now value of T that you have already obtained. That value of T was T equals to 35.1 Newton. So you can write W plus times positive times negative is minus here, and the value of T is now 35.1 Newton, and then we have sine 70 degrees. So that gives you W equals to 35.1 times sine 70 degrees. Take your calculator in degree mode and then calculate it. And my value I have got as this is 32.9697 and something like this. So if you round this off up to the 3 significant figure, that means correct to the 3 significant figure, is going to be nearly equals to 33 Newton. So weight of this particle is 33 Newton. And alternatively, in the light of this angle, which is 20 degrees, then along this line, the component of T is horizontal in this case. So with respect to this angle, 20 degree, horizontal component for T is here, T cos 20 degrees, and its vertical component, this will become vertical component with respect to angle 20 degrees. So it will be T sine 20 degree. So again, as the particle is in equilibrium state, then these two forces balance each other, and hence the total sum of the forces on this particle is 0. So suppose this as towards one direction as positive direction. So then in that case, the total force will be T cos 20 degrees plus minus W, or you can write W plus minus T cos 20 degree equals to 0. And then therefore your W value in this case will be, if you transpose towards W towards right, then it will be plus W. And then the value of T we have already obtained in question number 1, part 1 of this question. So it is, if you are left with here 35.1 and times it is cos 20 degree. Take your calculator again, you will see that the value of force is equivalent to 33 Newton. That means in this way also, if you try, the magnitude of this weight will be 33 Newton. So in this way also we can calculate the weight. So even though this question is not that complicated, but I'm trying to do in different ways in order to make your concept clear. So this is for the practice mode of solving the problem, but in exam you try by using only one way. Okay guys, if for example one of the values of T or W is known, in that case we can apply some alternative sense also, provided that if W is given or if T is given in this case. So you can see now we worked out with the component of the force T. Now we can also work out with component of the force 12 newtons. So for example, if you take the line this way, okay, and then you can see this this is 20 degrees, so this is vertically opposite angle, this is again 20 degree. So and then this angle is definitely going to be, this is 70 degree, because the whole angle up to here is 90 degree. Okay, so here you can see that in along this direction, this particle is acted upon by two forces. One, the force 12 Newton applied to this particle, and another force is the weight of this particle. So if I'm considering the component for this 12 Newton force, so because this 12 Newton force makes angle 70 degree with this line, so horizontal component for this 12 Newton will be here 12 cos 70 degree, cos 70 degrees. All right, and then its vertical component will be somewhere like this. So this is 12 sine 70 degree. Okay, next, because now we resolve this W, uh, that is weight of the particle P. So here in this case you can see that the weight of the particle acts vertically downwards and makes angle 20 degree with this line. So you can suppose this as the horizontal component for W. So in case of W, what you can write here, this is W cos 20 degrees, and its vertical component, which is perpendicular to this point, will be the same thing over here. That will be W sine 20 degrees. So again, since the particle is in equilibrium state, the total force will again be 0. So in this case, if you consider like one force as T, so you can write here T, and opposite forces you can put minus sign over here, because this both of these forces are opposite. So this lines of force has two forces, one as 12 cos 70 degree and another as W cos 20 degrees, and that equals to 0. And now as we are going to find T or W, that means if you are going to find T, W must be known, or if you are going to find W, T must be known. So I'm talking of to find T in this case. So this is T minus, this is 12 cos 70 degrees plus, and value of W is 33 Newton nearly. So it is 33 cos 20 degrees. All right, and that is equals to 0. So if you take a calculator and then if you calculate it, you'll find that the value of T is again 35.1 Newton. It's okay. So this lesson was not only to solve the problem, but to let you understand the strategy to solve a problem. So always take the problem in two ways: one in practice mode, another as exam mode. While you are in practice mode, you try the same problem in different ways, but while in your exam mode, you try the problem in the way you feel it is easy to you. All right. So this is all for now, and thank you for your patience.